Okay, so this question is question 22 from exercise 7.4 of the Text and Tests 4 textbook. And this is a differentiation question where we're looking at, we have a curve and we have a tangent to that curve, and specifically we're looking at what that tangent does. So to give you a very quick sketch, if you imagine some sort of curve that looked like that, and let's say we have a point, and there that point then creates a tangent to the curve at that point. That tangent then intersects the x and y axis. So what are those two intersection points? Okay, and therefore we'll know what the height is and what the base is in the sense of my right angled triangle, because the axes intersect at right angles, and we'll do area equals half base times height. Okay, so we will just, I tell you what we'll do is we'll call that point there B, comma naught, and we'll call this point here naught, comma H. Okay, to keep in with the terminology of H and B. So, and the point there where the tangent is intersecting the curve is 2, 1/2. So let's just work this through. Let's first of all work out what the tangent equation is, and then after that we can worry about what the area of the triangle is. Okay, so and I suppose just very quickly, just in terms of the question, it meets at capital A and it meets here at capital B. Okay, point B. So now my little b is going to be slightly confused. But anyway, we're just going to stick with the terminology that I've used there. Right, okay, so the tangent to the curve. So straight away, if I want a tangent, I need to know its slope. If I want to know its slope, I need to differentiate. So let's first of all put the function in index format, which is 3 times by x to the minus 1. So if I'm going to differentiate that, power multiplied by coefficient, reduce the power by 1. So I could write that as being minus 3 over x squared. Now that gives me the slope of the curve. So now we can work out the slope specifically at the point 2, 3/2. So the x value is 2. So my slope of my tangent, and indeed the slope of the curve at that point, okay, when x is equal to 2, is going to be minus 3 over 2 squared. That's minus 3/4. So that's the slope, okay, of the tangent. We have a point 2, 3/2. So using those three pieces of information, we can use the equation of the line to work out the tangent line. So y minus 3/2 is equal to slope of minus 3/4 multiplied by x minus 2. So that's me substituting those three numbers, okay, into the equation of the line. So at this point in time, I can sort of multiply out the brackets and so forth and tidy up. So I will end up with, hang on, it's a different pen. So we'll end up with 4y minus 6 is equal to minus 3x plus 6, which comes to 3x plus 4y minus 12 equals 0. Okay, that's me very quickly multiplying out all the brackets and so forth and getting an answer. You'll have various ways which you'll choose to multiply that out and tidy it up. Just very quickly, alternatively, you might want to have it in the form of y equals mx plus c, in which case we'd have minus 3/4 of x, and we would have 3 there. So minus 3/4 of x plus 3. That 3 there is gained by having positive 6/4 and then adding on 3/2. So it gives you plus 3. So whether you have it in this format, the ax plus by plus c equals 0 format, or y equals mx plus c format, doesn't really make much difference. Your task now, okay, is to find your intersection points. Okay, the point that we've called A and B. So there's a variety of different methods of doing this. If I'll just go through using the equation in this format here. When you want to find intersections with axes, you just say x equal to 0 and solve for y, and likewise y equals 0 and solve for x. So when x is 0, I'm going to get a situation where y is equal to 3. So we know that the h value, okay, we've got the point 0, 3, the height is 3, and when we put in y equals 0, we end up with a situation where x is equal to 4, i.e. the point 4, 0. Okay, my base is 4, and so we have a height of 3, we have a base of 4, and when we work out a half base times height, we end up with our area, which is 6 square units. Okay? So the answer numerically is 6.